Hey everyone, here we have a quick question on systems of equations, and we have a few of these up on the site, but they're usually with two equations and two variables, so x and y. Now we have a system where there are three equations but three unknowns. So we have an x, a y, and a z that we're trying to solve for. So remember that when it says solve this system of equations, what we're really looking for is a value for each of the variables in the equations that work in all three equations. So ideally, we're going to end up with an answer that has x equals something, y equals some number, and z equals some number, and those three numbers will work in all three of these equations that we're given. Okay, so that's what we should see when we're done. So we want to follow a specific set of steps in order to get there. So the first step is to grab two of the three equations and eliminate one of the variables, I should say. Now we know with elimination, the easiest way to, the way we want to eliminate is to match coefficients on the same variable. So what that means is I'm going to take a quick look down at the coefficients in front of all the x's, the coefficients in front of all the y's, and the coefficients in front of all the z's. There aren't too many that kind of match up, but I do see that in equation 1 and equation 2, so these two here, there's a negative 1 in front of y in the first equation and a positive 1 in front of y in the second equation. That means that if I add those two equations together, I'll get rid of y. So that's what I'm going to do. So I'm going to say 3x minus y plus 2z equals 0. That's the first equation. And I'm going to add that to the second equation, which is 2x. I'll put this in brackets, 2x plus y plus 3z equals 5. Now when we add this straight down, up and down, it's 3x plus 2x is 5x. Negative y plus y is 0, which is exactly why we chose these two. And 2z plus 3z equals 5z equals 0 plus 5 equals 1. 0 plus 5 equals 5. There we go. Okay, so we have 5x plus 5z equals 5. That is one of our new equations, which we got from eliminating y. So now what we need to do is we need to take another pair of equations. So we did equation 1 and 2. We now want to either use 1 and 3 or 2 and 3. And we want to eliminate the same variable. So I'm going to take 2 and 3 just because it doesn't really matter in this case. So 2x plus y plus 3z equals 5, and x minus 4y plus 6z equals 7. Okay, so this is equation 2 and 3, and remember we want to get rid of y as well because that's what we did to get our first new equation here. Problem is, we have a coefficient of 1 in front of y in the first equation and a coefficient of negative 4 in the second equation. So whether we add or subtract these equations together, it won't get rid of y. So what we need to do is we need to multiply this first equation by 4 so that the coefficients match up, and then when we add or subtract, it'll get rid of it. So I'm going to multiply everything in the equation by 4. Make sure you do it to both sides. So 4 times 2x is 8x. 4 times 4y is positive 4y. 4 times 3z is positive 12z, and 4 times 5 equals 20. So that's perfect. The second equation doesn't need to change, so I'll just rewrite it underneath here. Plus 6z equals 7. Okay, awesome. Now we are ready to once again add these two equations. The reason we're adding is because we have a positive 4 and a negative 4 in front of the y's. Positive plus a negative equals 0, so that'll get rid of the y's, just like we wanted. So 8x plus 1x is 9x, plus 4y minus 4y is 0, which we want. 12z plus 6z is plus 18z, and 20 plus 7 is 27. Do not forget to add the right side. People often forget that. Great. So the good thing about this is now we've, instead of 3 equations and 3 unknowns, we've got it down by eliminating y in 2 sets. We have got it down to 2 equations and 2 unknowns. So that whole first step, I'll call it step 1, was eliminate the same variable from two pairs of equations. So that's what we did. We took the first and second equation, eliminated y. Then we took the second and third equation and eliminated y again. Now we've got two equations, two unknowns, which we can use the methods which we've learned in the previous videos to solve. So I'm just going to rewrite them down here. So we have 5x plus 5z equals 5. We have 9x plus 18z equals 27. Okay, elimination doesn't look to be the easiest method here. And that's because 5 and 9 don't really match up very well. 5 and 18 don't match up very well either. You'd have to multiply both equations. So I'm going to simplify this first equation, and I'm actually going to use substitution. So I want to get x on its own in this first equation. So I'm going to say 5x equals 5 minus 5z. So I just subtracted the 5z from both sides. And then I can say divide by 5. So I get x equals 1 minus z, because I just divided both of those terms by 5. Perfect. So now that I have x on its own in terms of z, I can substitute in to x here. So in this question, I'm using a combination of elimination method to get from 3 variables down to 2 variables, which I would always recommend when you're at the 3 variable stage. Substitution gets really, really messy when you try and use it with 3 variables, but with 2 variables, as you can see here, it's pretty easy. So now I say 9, and instead of x, it's 1 minus z, because I'm substituting that in, plus 18z equals 27. I'm going to multiply this through. 9 minus 9z plus 18z equals 27. So then I get 9 plus 9z equals 27. 9z equals 18. So z equals 2. Once you found one of the variables into it as its actual number, I would recommend putting a box around it so you don't get lost. Now you just work your way back up the ladder of what you did, because we went from 3 variables down to 2 variables down to 1 variable. We found that 1 variable, now put it back into the 2 variable relationship. So we said x equals 1 minus z, so x equals 1 minus 2, because z is 2, so x equals negative 1. Perfect. Now we have 2 variables. We're just looking for that third, so you can put it back into any of the first 3 equations. Let me make some room here. Okay, so now we can just put x equals negative 1 and z equals 2 into one of the first equations. So I'll put it right in the first one. So I'll write 3x minus y plus 2z equals 0. That's this first equation here. But now 3, I know what x is negative 1. We don't know y. Plus 2 and z is 2 equals 0. Negative 3 minus y plus 4 equals 0. 1 minus y equals 0. So y has to equal 1. And that's our solution. It's negative 1, 1, 2. That's x, y, z. That's our final solution. So step 1, eliminate the same variable from 2 pairs of equations. Once you do that, we chose to eliminate y from 2 pairs. You can eliminate x from 2 pairs. It doesn't matter. Once you do that, you get down to 2 equations with 2 unknowns, and then you just use either substitution or elimination to get down to the 1 variable, and then work your way back up, substituting the values back in. Hopefully this was helpful. If you have any other questions, email info@arnoldtutoring.com. Thanks so much.